Before starting the video, I would like to make an announcement that our fellow educator, my fellow friend Akash Sarkar, is now taking special classes on an academy. He has started today. Today 9 p.m. would be his first class. Make sure to attend that class, everyone. It's very important. He would teach something like inequalities. You can see this is the special classes link. Here I have given it. Go to unacademy.com, search Akash Sarkar there. He teaches in IIT-JEE category. Don't forget that. And if you want the direct link to his profile, I am pinning it here. Let me increase the size of the text so that you guys can understand. Here is the Unacademy link profile. So please guys, everyone follow him. He would continue to give free classes there also. You won't have to pay for it or anything. You just have to follow him. I have already followed him, of course. Make sure to hit follow. And so now let us get into our actual video, in which I will discuss. I am Anik Mukhopadhyay, by the way, and my face is not being shown because I am ugly. I would discuss a magnetism sum which will clear a lot of concepts for you. So let's get started. Hello guys, it's me here again, Anik Mukhopadhyay. If you guys are wondering why today my face is not being shown in the camera, that's probably because suddenly I have come to the divine realization that I am a very ugly person. Whatever, it's just a technical error. So let us get started with another very interesting problem. It's not as difficult as the usual problems I discuss, but I chose to discuss this problem because this has a very interesting application in actual engineering and physics. So see, what is it told? The charged particles having various velocities are sent through slit S1. So there is a hole here. Through here charged particles are sent, and they only a certain type of particles, as it told, they enter a velocity filter where a uniform magnetic field of this is there. Okay, and only a few particles emerge from the outer hole undeviated. Now what is a velocity filter? Let me explain the concept here shortly. Suppose there is a particle with a velocity v, right? Now in one direction, suppose right, we have an E vector which is an electric field. Suppose this also has a charge q. Of course the particle has to be charged. So on this particle, a force due to electric field equal to QE would be here, right? So it should be deviated to the right hand side. Now suppose, to make things worse, I added a magnetic field also, B vector. Now what would be the force due to magnetic field? Just Q into V cross B. The direction, what would be the, I can't show my hand, but you can use the right hand rule to find out. The magnetic force would be in the left hand side, Fm. So if we want the particle not to be deviated, for no deviation, let me write that down. The two forces need to be equal. So let me write QE equal to Fm. Fm is Q into V cross B, which would be nothing but QVB sine 90, which is 1 because the angle between V and B is 90 degree. Let me scroll down a bit. On simplifying this, we can get that QQ gets cancelled out and V would be equal to E by B. Now this V is nothing but the velocity of the particle, right? This is the velocity. And who decides this E and B? We decide, because we create the apparatus, we decide this. So what's the usage of this is, suppose we want particles of exactly velocity of suppose 5 meter per second. Now how can we create particles of speeds? We can accelerate them through a potential difference. Of course some particles will get more kinetic energy, some less, because our process is not ideal. So what does that mean? There would be a deviation in the velocity of the particles, but for our experiment we need exactly this velocity. So what would we do? We will set E and B such that only this V exact type of particles come out of the apparatus. This apparatus is known as the velocity selector apparatus. Let me write, this is the concept of velocity selector, and this is nothing but a velocity selector here. So using this only, which I already wrote, we will get that V equals to E by B of the particle, V of the particle. Now E is 100 and B is 0.1. This would give us 1000 meter per second. In the engineering terms, we write it 10 to the power 3 meter per second. Now let me scroll down again. In the second part, we see that the electric field is now absent. So the particle of Vp just went in, and what is there? Just magnetic fields are there. Magnetic fields are there. It is told that the particle traces out a semicircle which has a diameter of 0.48 meter. Now, what would we understand from that? Extremely sorry, I wrote it as 0.48 meter. It would be 0.42 meter. I copied it wrong. 0.42 meter. So that means its radius is 0.21 meter, using my excellent math skills. So when does a particle create a semicircle? Now try to understand again by the right hand rule. The velocity is in the upward direction and the magnetic field is in the inward direction. So you can see at all times the force due to magnetic field would be perpendicular to the velocity, and if the force is perpendicular to the velocity, it will cause a centripetal acceleration. And what is caused by the centripetal acceleration? That is correct, a uniform circular motion. So this is the Fm. So you can see that the Fm, magnetic force, is nothing but the centripetal force. Centripetal force formula is mv square by r, and Fm was qvb. Again, I omitted the sine theta because we already know the value of that. From here we get r equal to mv by qb. Now we would just plug in the values. R was 0.21 meter, equal to m we don't know, q we don't know. Let us keep it like this. B, it's 0.1 Teslas again, and V, it was 10 to the power 3. So on simplifying this, what do we get? 0.21 into 10 to the power 4. Sorry, it would be 0.21 divided by 10 to the power 4. 0.21 millimeter, so 0.21 into 10 to the power minus 3 meter, because we have to convert everything into the SI units before the calculation. As in the question everything is in the SI unit, our calculation also have to be in the SI unit. So 0.21 into 10 to the power minus 3 divided by 10 to the power 4 equal to m by q. So from here, q by m would have a value of 10 to the power 4 by 0.21 into 10 to the power minus 3. Let us use a quick calculator to do this. This would give us a value of 4.76 into 10 to the power 7 coulomb per meters. So this is the particle's charge per mass ratio. Now how do we understand what's the particle from this? Well, it's pretty easy. It's given that q by m of a proton is equal to 9.8 into 10 to the power 7, right? So what's it? Q of proton by mass of proton. Now what is helium plus is q by m? Helium plus is nothing but a helium nuclei which is doubly ionized, right? So it has twice the charge and 4 times the mass. So it has half the ratio of qp by mp, which would give us half of 9.8 into 10 to the power 7, which gives us approximately 4.8 into 10 to the power 7, which approximately coincides with our findings here. Now the inaccuracies are caused by not taking everything to the required accuracy of significant digits. But from here we can see that the Q by M of helium nuclei, or this thing is also called an alpha particle, you will learn about it more in the radioactivity chapter, this matches with our experimental findings. So we can conclude that our particle, our found particle, was an alpha particle. Now let us see which option was correct. We can see that option A is correct. From option B we extracted the information. Option C and D you can try to see if these are correct or not. This would also come as wrong, because one of them would approximately come as 4.4, one of them will approximately come as 4.2 or something like that. You can try. I would really suggest that you try this at home. Please try this at home. The opposite of don't try this at home. So that was the video, guys. Thank you. And as per popular demand, I have completely disabled / very lowered the volume of the background music because it was irritating to some people. So thank you for watching. Please like, share and subscribe. That was the video.